In this lesson, we are going to go over your study guide for test 3. Your test will consist of approximately 20 to 35 questions. There are many examples on your study guide. I'm sure you freaked out by the 10 pages on your study guide. However, there are so many examples. That way you have enough practice so you can do well on the test. This will cover sections 2.3, 2.4, 3.1, 3.2, and 3.3. So we're going to start with section 2.3, which covers two variable equations. The directions state to determine which of the ordered pairs are solutions for the given equation. So the first thing that we should do is identify our x and our y for each ordered pair. So for this first ordered pair, we have 6 for our x and a 0 for our y. So if they're asking us to determine which of the ordered pairs are solutions for the given equation, we're going to put a check mark if it is a solution, and we're going to put an X if it's not a solution. We know it's a solution if we get a number equal to another number. We know it's not a solution, let's say if we got 5 equals -5. Those two numbers aren't the same, so that means that we would not have a solution. So let's plug in our variables. Remember, when you plug in a number for a variable, you should always use a set of parentheses. So our x was 6 minus our y is 0 equals 6. So 6 minus 0 is 6. Since 6 equals 6, that is a solution. So we would put a check mark there. Next, I have 3 for our x and then a 3 for our y equal to 6. So 3 minus 3 is 0. 0 does not equal 6. So this is not a solution. Next, we're going to look at 3 and -3. So I'm going to plug a 3 in for my x and a -3 in for our y. So I have 3 minus -3. Well, your rule is keep, change, opposite. So that now gives us 3 plus 3. We know 3 plus 3 is 6. 6 equals 6. So we know that is a solution. And then finally, let's look at 0, -6. I've got a 0 for my x, a -6 for my y, equal to a 6. So again, keep, change, opposite. So that would be 0 plus 6, which is 6. Bring this other 6 down. Since we got 6 equals 6, we know that's the correct answer. We know that they're solutions, so we would put a check mark. Now let's move on to problem number 2. This one's a little more intricate. Remember, you should label your x and y values. Make sure that you realize that for homework purposes, I need to at least see how you plugged your numbers in. So for example, problem number 1, I need to at least see this step right here where you plugged all of those values in. That lets me know what you're doing to actually solve or to evaluate and make sure that you are working through these problems and you know where you're supposed to plug stuff in when. So I've got 2x plus 3y equals 6. So I'm going to plug a 3 in for that x and a 0 in for that y. So I have 2, my x was 3, plus 3, my y was 0, equals 6. So you should use your order of operations. So we're going to multiply these numbers and these numbers first. 2 times 3 is 6. 3 times 0 is 0. And then 6 plus 0 is 6. Since 6 equals 6, we know that that is a solution. Now let's look at the next one. We've got a 6 and 2. So I've got 2 times 6 was my x, so I'm going to plug 6 in here, plus 3 times y was my 2 equals 6. So multiply these first and then we're going to add. So 2 times 6 is 12, 3 times 2 is 6, so that's 12 plus 6. So 12 plus 6 is 18. 18 does not equal 6, so we're going to put an x there. That is not a solution. Next, we've got negative 3 at 4. So I'm going to plug in a negative 3 for my x and a 4 for my y, and bring that 6 over. So we've got 2 times negative 3 is negative 6. 3 times 4 is 12. So negative 6 plus 12 is a positive 6. Remember that rule is that when you are adding and your signs are different, you should subtract those numbers. So 12 minus 6 is 6, and you keep the sign of the bigger number. So since 12 was my bigger number, my number was going to be positive. So 6 equals 6. So we know that is a solution. Now let's look at the last ordered pair of 0, 2 on this problem. We've got 2 times x was our 0, so I'm going to plug 0 in for x, plus 3 times 2 is our y, equals 6. So 2 times 0 is 0, plus 3 times 2 is 6. So 0 plus 6 is 6, so that means that since we got the same number on each side of that equal sign, that means that we now have a solution, and we're going to put a check mark there. Let's move on to problem number 3. I'm going to label all of my x and y values. Sorry about that. So I'm going to plug in a 5 for my x and a 2 for my y. So I'm going to multiply my 2 times 5 first. That gives me a 10. Bring down my minus 2. Oops. So I get 10 minus 2 equals 8. So 8 equals 8. So that means that 5, 2 is a solution. Now I've got 4, 0. So I've got a 4 for my x, a 0 for my y. So I have 2 times 4, which is 8. Bring down your minus 0 and your equals 8. 8 minus 0 is 8. So 8 equals 8. Since they both equal the same number, that means that 4, 0 is a solution. Okay, so now I've got 0, 8 for my answer. So let's see. Plug a 0 in for x, and an 8 in for y. Bring that 8 down. So 2 times 0 is 0. Remember, anything times 0 is going to be 0. And then bring down your minus 8. So 0 minus 8. Think about this in money terms. You have $0 in your bank account, so you're even. And then you take $8 out because you go to some restaurant, spend $8. So that was $8 you didn't have. So now you are in the negative, meaning you owe that bank $8. So negative 8 equals 8. Those do not equal each other. They're not the same thing. So that means that our 0,8 is not a solution. So now let's look at 6, 4. So I've got 6 for my x, 4 for my y. So 2 times 6 gives us 12. Bring everything else down. And then 12 minus 4 is 8. 8 equals 8, so that is a solution. I know on each one of these problems that we've done, there have always been 3 solutions and 1 that isn't a solution. That is not always going to be the case, so don't become accustomed to that once you find the solution that doesn't work, don't automatically think that every other one is going to work. You can always, you could have no solutions, you could have all 4 of them be solutions, or a mixture of that. So be careful there. So now on the next page, I have directions that say complete the ordered pairs so that each is a solution for the given equation. So they either give us an x value or y value, and they say fill in the blank. So I'm labeling everything just so I know where my x's are and just so I know where my y's are. So whatever value they give me, I'm going to plug into the equation. So here, they don't give me my x, so I'm just going to rewrite it. And they tell me my y is a 4. So I'm going to plug in that 4 in place of where the y is, and bring over my equals 7. So that says x minus 4 equals 7. So in order to solve for x, we would need to get that by itself. So this tells us what is on the side where the x is. It's always through the equal sign. So that 4 is in the way. So the way we get rid of that 4 is by adding 4 to both sides. If you forget how to do this, then you can look back at sections, I believe, 1.4, 1.5, and 1.6. So that gives us x equals 7 plus 4, which is 11. And that is our solution. If you would like to double check and make sure that 11.4 is a solution, you can do what we did in the very first 3 problems and plug 11 and 4 into both your x and y. That's just a backup to make sure you did everything right. So now we've got a 15 for our x. So they tell me x is 15, but we don't know what y is. So to get that y by itself, remember you can draw that line through the equal sign if you wish. We need to get the 15 out of the way. So we're going to subtract 15 because that makes those cancel, leaving us with a negative y equals negative 8. So this y has an understood 1 in front, which makes it a negative 1y. I don't want to know what negative 1y is. I want to know what positive y is. So I'm going to divide each thing in my problem by a negative 1, which gives me y equals a positive 8. So that would be my answer for the second problem. And then I have a 0 for my x, and I don't know what y is. So 0 minus y, well, that 0 isn't doing anything, so we have negative y equals 7. Again, there's an understood 1 in front, so we could divide each side of the equation by negative 1, which gives me y equals negative 7. So because 7 divided by negative 1 is negative 7. Now we have our last problem in this. We have blank 0. So they don't tell me what my x is, but they tell me my y is 0 equals 7. So x minus 0 is just going to leave me with an x. I'm going to bring down that 7. So x equals 7. Okay. So now that problem 4 is complete. Now let's look at problem number 5. So I'm going to label everything as my x and my y. Okay, so I have a 0 for my x value, and I don't know what my y is. So 0 minus 3y is just going to give me a negative 3y. And to get that y by itself, you would divide by a -3. You may have been tempted to divide by a +3, but had you done -3 divided by +3, what I would have given you a -y. But you don't want a -y, you want a +y. So that's why we divide by that same sign to make sure that those cancel. So I have y equals -3 because a +9 divided by a -3 is a -3. Okay. So now we can look at the next problem where we have 12 blanks. So I have a 12 for my x, and I don't know what my y is. So to get that y by itself, the first thing we're going to do is subtract 12 from each side. So that gives me -3y equals -3 because 9 minus 12 is -3. And then to get that y by itself, we would divide by a -3 so we could get that to cancel, leaving us with y equals -3 divided by -3 is a +1. Next we have blank 0. So we don't know what our x is, but we know that our y is 0. So to solve, the first thing we should do is multiply that -3 and 0. So I've got x, and then -3 times 0 would mean that we were minusing 0. X minus 0 is just x. So x equals 9. And then our last problem in this, number 5, we don't know what our x is, but we know that our y is -2. So to get our x by itself, we're going to multiply these two numbers together first to get x plus 6, because negative times a negative is a positive, and 3 times 2 is 6. And to get that x by itself, we're going to subtract 6 from both sides, which leaves us with x equals a +3. Okay. Now let's look at problem number 6. So I'm going to label my x and my y values. So on my first ordered pair, I've got 0 for my x and blank for my y. So I'm going to plug a 0 in for that x. I don't know what y is, so I'm just going to rewrite it. So the first thing I'm going to do when I'm solving for y is I'm going to multiply that 2 times 0. 2 times 0 gives me 0. Bring down the 5y equals 20. 0 plus 5y is just 5y. Bring down your 20. And to get that y by itself, we're going to divide everything by a 5. So y equals 4. Next I have 5 blank. So I know that my x is a 5. And I don't know what y is. So 2 times 5 gives me 10, plus 5y equals 20. So I'm going to subtract 10 from both sides to get that y closer to being by itself. So now I have 5y equals 20 minus 10 is 10. And then I'm going to divide each side by 5 to get y equals 2. So now I have blank 0 for my next problem. So I don't know what my x is, but I know my y is 0. So I'm going to multiply these two numbers together first. So that gives me 2x plus 0, because 5 times 0 is 0, equals 20. 2x plus 0 is just 2x. And then to get that x by itself, I'm going to divide by 2 to get x equals 10. Now we're going to look at the last ordered pair for this problem, which is blank 6. So I don't know what my x is, but I know my y is 6. So the first thing I should do is multiply those two numbers together to get 2x plus 5 times 6 is 36 equals 20. I don't know why I just said 36. I lied. 5 times 6 is 30. Sorry, you guys. Bring down your 20 and you still have your 2x. So again, I apologize. 5 times 6 is 30. I don't know why I was thinking 6 times 6. So now to get that x closer to being by itself, we're going to subtract that 30 from both sides, which leads us to 2x equals negative 10. You've got 20. You spend 30, so you owe the bank $10, so that's how we have a negative 10. And then we divide both sides by 2 to get x equals a negative 5. Be careful about your negatives. Okay. That's it for problem number 6. Okay. So the directions here say give the coordinates of the labeled points on the graph. So on number 7 we have A. So we find A on our graph. It's right here. So you know in an ordered pair you always have your x value and then your y value. So you first travel on your x-axis and then you travel on your y-axis. Everything starts at the origin, which is where your two axes intersect. And I'm going to go to A. So I travel on my x-axis first. So I'm going to go until I find what line A is on. 1, 2, 3, 4. So since I went 4 spaces to the left, that would be a negative 4. Because remember, left is negative, right is positive, up is positive, down is negative. Okay, so then I'm at negative 4 for my x, so now I'm going to go up to find my A. 1, 2, 3 spaces. So that home location, that coordinate is negative 4, 3. So now I'm going to, for number 8, look for B. So I start here at my origin. Well, B is right here. So I actually don't want to go left or right any spaces, because if I do, I leave this line. So that means my x value would be 0. And then to find my B, I would go down 1, which would mean negative 1. Now I have C. The C is right here. So again, I travel on my x-axis first. 1, 2, 3, 4, 5. So I'm going to go negative 5 for my x value. And then I'm going to go down to find C. So I'm going to go 1, 2, 3, and 4 spaces to find my C. So since I went down, that would be a negative 4. Remember, in class, we would have drawn this chart that says that we had the quadrant 1, quadrant 2, quadrant 3, and quadrant 4. Quadrant 1 was a positive, positive. 2 was a negative, positive. 3 was a negative, negative. And 4 was a positive, negative. So if you are unsure if you are doing the right thing, giving the right sign for each number you write down, you can refer back to this chart and it tells you what each chart should have, or what each point should have for its signs. So number 10 is D. So I've got D right here, and I'm going to apologize for the cat meows. They're a little jealous right now. So I've got a D. So I'm going to go right 6 spaces, it looks like. So let's look. 1, 2, 3, 4, 5, 6. So I went to the right, so that would be a positive and a 6. Now I don't want to go up or down any, because if I do, I leave my dot. So since I'm already there, I'm going to put a 0 for my y value. And then finally for number 11, I've got E. E is right here. So remember, you go in your x-axis first. So I've got 1, 2, 3, 4. It's in a positive direction, so I go 4 to the right. And then to go to my E, I'm going to go down, so that would be 1, 2. So that would be a -2 since I went down. Okay. The next set of directions say to plot the points with the given coordinates. So we're doing the opposite of what we did on 7 through 11. So they want us to plot the point 4, 0. So it all starts at the origin. You're going to go 4 spaces on your x-axis, 1, 2, 3, 4, and 0 spaces up or down. So that means that my point is actually going to lie on the x-axis. And I'm going to put a dot and then a P next to it. Don't forget to label them with your variables so I know which number or which dot goes for which problem. And then for 13, I've got Q is 5, 4. So I'm going to go to the right 5 because it's a positive 5 on my x. 1, 2, 3, 4, 5. And then I'm going to go a 4 on the y, and since it's positive, I go up. 1, 2, 3, 4. So that gives me my Q. Now, for number 14, I have T, which is -2, 4. So I start at my origin, and I go 2 to the left because it's a -2. 1, 2, and then a positive 4, so that means I would go up 4. 1, 2, 3, 4. And that was our T. Okay. Finally, I have my U. I'm going to start at my origin, and I'm going to go to the right 4 because it's a positive. So 1, 2, 3, 4. And I'm going to go down 2 because it's a negative. 1, 2. Now be very careful. A lot of students get this confused. When you're plotting points, you always do your x first and then your y. A lot of people get confused and because they hear rise over run taught a lot, so they feel like they should do the up and down first since it says rise, and then do the left and right since it says run. Rise over run is only when you are plotting your slope. One final thing I would like to say is notice how my dots are all very small. They're not completely huge, but they're big enough to where I can see them. Please make sure that you are not obnoxious with your dots because then your graph becomes a little less accurate. So make sure that we don't do that. Make sure that they're just nice and small like those. Okay, so for problem numbers 16 through 21, the directions say to give the quadrant in which each point is located or the axis on which the point lies. So I'm going to draw this again. It was on our other page we just did, but I'm going to redraw it for you. Okay, so this is quadrant 1, quadrant 2, quadrant 3, and quadrant 4. If you ever forget, remember this is the Cartesian or coordinate plane. So it's always going to start at the top right corner and they're going to go in order of the C for coordinate plane, also known as counterclockwise. If they lie in quadrant 1, then you would have a positive, positive. Quadrant 2 is a negative, positive. Quadrant 3 is a negative, negative. And quadrant 4 is a positive, negative. If something lies on the x-axis, then it would go however many numbers on the x-axis and then it would be a 0 for the y value, because if it went any other number up or down, it would no longer lie on the x-axis. And if it lied on the y-axis, it would go no spaces left or right, so the x value would be a 0, and then it could go however many numbers up or down. It doesn't really matter for that, as long as your first number is a 0. So you can tell by your signs as to which quadrant your point will lie under, and then when you see a 0 in your x or your y value, that lets you know, hey, my point is actually going to lie on an axis instead of in a quadrant. So on number 16, I've got a positive, so that means it's going to be quadrant 1. Again, you do not have to use Roman numerals. I was just taught to do so, so I've always used them. On my tests, I really don't care which one you decide to use. Number 17, negative, positive. That would lie in quadrant 2 because we've got a negative and then a positive. Okay, number 18, we've got a negative, negative. It's going to lie in quadrant 3. And then number 19, we have a negative 5, 0. Well, that 0 indicates to us that it's going to lie on an axis and not be in a quadrant. So it looks here, if you look at your x-axis, it lets you know that if you have a number and then a 0, which we have on number 19, then it's going to lie on the x-axis. And then if we look at number 20, it's a 0 and then a number, which means it'll lie on our y-axis. If you need to draw your own little coordinate plane down here so you can practice plotting them to see where they're going to lie, I don't care. That doesn't bother me at all. And then problem number 21 is a positive, negative, which is going to lie in quadrant 4. Okay, now let's look at graphing. This is moving on to section 3.1. Remember, you had steps for graphing. If you look at the 3.1 video, your first step is always going to be to put your equation in that slope-intercept form, which is y equals mx plus b. So we want to get the y by itself, so we're going to subtract x from both sides, which leaves us with y equals negative x plus 5. We want the x value to come first, because that's what our formula says. Oops. Want our x value to come first because that's what our formula says, and it stays a negative, okay? You cannot say minus 5x because that means you're multiplying that negative 5 and x, and we're not doing that, we're subtracting. Next, your step is to identify your m and your b. Your m is always the number in front of x, so in this case it would be a negative 1, and you also know that your slope is always a fraction, so it would be negative 1 over 1. And then your slope is a 5, your y-intercept is a 5. It's always that last number. So after you have put your equation y equals mx plus b form, and then identified your m and your b, then you need to plot your y-intercept from your origin. So you start at your origin, and you go to positive 5, which is up. I put my dot. Then your directions say that you are going to plot your slope 2 times from the y-intercept. Put your pin on the y-intercept, and it's rise over run. So rising means like that you're going up and down, okay? So if I'm rising in a negative direction, that means down. And then if you're running in a positive direction, running is from left to right. So running in a positive direction would be to the right. So I'm going to go down 1 and to the right 1. So starting at my y-intercept, I'm going to go down 1 to the right 1. And then I have to do it 2 times. So I'm going to do it again. Down 1 to the right 1. If you want to keep going, you are absolutely more than welcome to do so. But for the purposes of the test, you have to have at least 3 dots in order for me to accept your graph. It may not be absolutely perfect, but you'll have a ruler to use on the test, so it should be close. So you need to take your ruler and put it through all 3 dots, and remember it should extend the whole way through your graph, and then finish up with arrows. So on problem number 23, I have y equals 5x. Well, that's already in our slope-intercept form, so step 1's already done. Step 2 is to identify your m and your b. Your m is always the number in front of x, so that would be a 5, and it's always a fraction, so it would be over 1. And your b is not written, so we would just make it a 0. Think about it. If you had a bank account and you wanted to add some number to your bank account, but it didn't need to change, then you would add a 0 to it. So if I just put plus 0 into this equation here, it wouldn't actually change anything about it. It just gives you a visual that your answer is for your y-intercept is a 0. So next you plot your y-intercept from your origin. Now since your y-intercept is a 0, that means that your graph is actually going to go through the origin, and then you're going to plot your slope from that, and you have to do it 2 times. So I'm going to rise in a positive direction, so that means up. I'm going to run in a positive direction, which means to the right. So I go up 5, and then to the right 1. But notice we have 2 dots, so we need a third, and we are now out of space. What we can do is swap the sign of each of these numbers to go the opposite way. So instead of a positive 5, I'm going to go a negative 5, and instead of a positive 1, I'm going to go a negative 1. So rise over run would now mean down 5, and then to the left 1. So I'm going to start at my origin, and I would go down 5 to the left 1. Now I have my 3 dots. I'm going to connect them. Notice how my line goes all the way through my graph, and I have finished it with arrows. So again, to show you that last dot, since it was off the screen, you would go down 5. 1, 2, 3, 4, 5, and then to the left 1 and put your dot. Okay. So on problem number 24, they've already put our equation in that slope-intercept form. So I've got y equals negative 3x plus 4. You've got your m equals and your b equals. So your m is your slope. Slope is always the number in front of the x, so it would be negative 3, and then you would put it over 1 for the rise over run. Okay? Then your y-intercept is always the number by itself, which was a positive 4 in this case. So the first step would be to plot the y-intercept from the origin. So I'm going to go to a positive 4, so that means I go up 4. 1, 2, 3, 4, and put my dot. Then you plot your slope from your y-intercept 2 times. So if I have a negative rise, that means I'm going to go down. And if I have a positive run, that means I'm going to go to the right. So I'm going to go down 3, to the right 1, down 3, oops, let me try that one more time. 1, 2, 3, to the right 1. Now that I have my 3 dots, I can go ahead and use my ruler to connect them. So I'm going to put my arrows at the ends, and I'm finished with that graph. So now number 25, they also have already put that equation in slope-intercept form for us. So we now identify our m and our b. Our m is a positive 3 over 1. Our b is a positive 2. So you plot your y-intercept from your origin. So I would go up 2 because it's a positive 2 for my y-intercept. Then I plot my slope from my y-intercept 2 times. So I'm going to start here. If my rise is positive, I go up. If my run is positive, I go to the right. I'm going to go up 3 to the right 1. And then if I go up 3, look what happens. 1, 2, I'm now out of space. So that means I have to change my signs and make this now a -3 and this now a -1. So that means my new directions are going to be down 3 and to the left 1. So I go back to my y-intercept and I'm going to go down 3 and then to the left 1. Now I have my 3 dots, so I'm going to connect them. Notice how my graph extends all the way through my graph. Notice how a lot of you guys try and stop your graph here. Okay? That's not what we want. We want it to extend all the way through the graph, okay? All right, now special graphs, problem number 26. In a special graph, if you remember what we talked about in class, if you have a special graph is when you have y equals a number or x equals just a number, okay? So I go on whatever axis it's equal to. So since it's the y-axis, I'm going to go to where y equals positive 2, and I'm going to put a dot. And it's going to slice that axis in half. So since this is my y-axis here going vertically, if I wanted to slice it, I would slice it here at a positive 2. So that actually means that your line is going to be horizontal. You might be thinking of it in the opposite way that it should go. Notice how my line extends all the way through the graph. This is the exception where you do not need 3 separate points in order to receive credit. And we're finished with special graphs. So now for number 27, we have x equals 5. So I go to my now x-axis to where I have a positive 5. So x-axis is here, and I would go to where it's a positive 5 right here. So since my x-axis goes this way, if I wanted to slice it, I would slice it in half like that, okay? So that means that my line is actually going to be vertical. Notice how my line goes all the way through my graph, and I put my arrows at the end. Now on problem number 28, I need to first put my equation in that y equals mx plus b form. So I'm going to subtract 2x from both sides to get 3y equals negative 2x plus 6. And then I need to get that y by itself. So I'm going to divide each term by a 3. Once I do that, I get y equals negative 2 over 3x. And then 6 divided by 3 is positive 2. So now I identify my slope and y-intercept. So my slope is a negative 2 over 3. And you can choose whether the negative goes in the numerator or denominator, as long as it's in one or the other. It cannot be in both, as long as your whole fraction is a negative. And then your y-intercept is a 2. So I start at my origin, and I'm going to go up 2. Then I do my rise over run 2 times. So if I rise in a negative direction, that means I'm going to go down. If I run in a positive direction, that means I'm going to go to the right. So we start at my y-intercept, go down 2, to the right 3, and then I would go down 2, to the right 3. We now have our 3 dots, so we can go ahead and work this. Notice how my line extends all the way through the graph, and I put my arrows at the very end. Now in problem number 29, to get that y by itself, I'm going to subtract x from both sides to get negative y equals negative x plus 6. And then I have a negative 1y. So the opposite of having a negative 1y, that means multiplication. So the opposite of that would be to divide by negative 1. That's how we get these to cancel. So I have a y equals negative x divided by a negative 1 is a positive x, and then a positive 6 divided by a negative 1 is a negative 6. Be careful about this problem. This one's really tricky. So I have my m is a positive 1, but remember you make it as a fraction, so you put it over 1. And then my b is a negative 6. Be careful because you've got that minus 6. That actually means negative 6. So now I go to my origin and I go to where I have a negative 6 on my y-intercept. So I go 1, 2, 3, 4, 5, 6. It's all the way down here. And then I do my rise over run from that point. If I'm going to rise in a positive direction, I go up. If I run in a positive direction, I'm going to go to the right. So start here, and I'm going to go up 1 to the right 1. Put my dot. And then I go up 1 to the right 1, and I put my dot. Again, if you wanted to keep going, you absolutely could. I would not count off any points. I was that student, if it surprises you, that wanted to keep going the entire way. It can only make your graph more accurate. But remember, you only have to have 3 dots in order for your graph to be accepted. Okay? So our last problem from graphing on section 3.1 is number 30. So we need to get that y by itself. So we're going to subtract 3x from each side to get 2y equals negative 3x plus 12. And then I'm going to divide every term by 2 to get y equals negative 3 over 2x plus 6. So now I identify our m and our b. Our m is negative 3 over 2, or you could have put in a positive 3 over negative 2. It doesn't matter which one you make negative as long as one of them is. And then your y-intercept is a positive 6 this time. So I go on my origin and I'm going to go up 6. 1, 2, 3, 4, 5, 6. I'm going to put my dot. And then I go down 3 to the right 2. So it would be down and then to the right. So I start here and I go down 3. So that would be 1, 2, 3, and then to the right 2. 1, 2. And then I'm going to go down 3 again. 1, 2, 3, to the right 2. 1, 2. So now I have my 3 dots. So now I can go ahead and connect them. Notice how my line goes all the way through my graph, and I have my arrows at the ends. Now the directions say, this is section 3.2, the directions say to find the slope of the line through each pair of points. So the slope of a line, we have the formula m equals y2 minus y1 over x2 minus x1. So whenever you work one of these problems, I recommend identifying your x and y on each ordered pair. Then, since this is my first ordered pair, this is my x1, y1. And since this is my second ordered pair, this is my x2, y2. So next, we are subtracting two numbers in the numerator and then subtracting two numbers in the denominator. So the way I teach my students to do this is to drew your two sets of parentheses with the subtraction in the middle on the numerator and denominator. So y2 was 8, y1 was 4, x2 was 5, x1 was 3. Then you subtract. 8 minus 4 is 4. 5 minus 3 is, sorry about that, 2. And 4 divided by 2 is a 2 over 1 or a 2. We are finding the slope. When you find the slope, you know that your slope is always a fraction, which is why I would accept either 2 over 1 or I would accept 2. For simplicity's sake, I'm just going to write a 2, but I would also accept 2 over 1 only because it is always a fraction. But normally in my class, you should know that you never leave these whole numbers over 1. So this is my x1, y1, x2, y2. I'm going to set up my parentheses. So my y2 is negative 6, minus my y1 is a 3, my x2 is a 1, my x1 is a negative 2. So I've got negative 6 minus 3. Y'all be real careful with these integers. Negative 6 minus 3 is a negative 9. Think about it. If you have overdrafted your account by $6 and then you spend $3 more, you've now overdrafted by $9. Or you could do your keep, change, opposite, and you're adding. Your signs are the same, so you add them and keep the sign. Over 1 minus negative 2. So keep, change, opposite. 1 plus 2 is 3. Negative 9 divided by 3 simplified would be negative 3 over 1 or negative 3. I would accept either answer. Problem 33. Draw your sets of parentheses, then your subtraction signs. I know that you might feel like those parentheses are tedious. However, ever since I started teaching how to do the problems this way, my pass rates have increased significantly. I think it helps you not make any mistakes when you are worrying about your signs. So this is my x1, y1, x2, y2. So that would be 2 and negative 2 and a 1 and negative 5. So 2 minus negative 2. Keep, change, opposite. So 2 plus 2 is 4. And then 1 minus negative 5. Keep, change, opposite. 1 plus 5 is 6. And to simplify that, you would put 2 over 3. I would want you to simplify it as far as you could. I would not want you to write your slope as 4 over 6. I would want you to write it as a 2 over 3. And then problem number 34. This is my x1, y1, and x2, y2. So I draw my parentheses. So my y2 is 3, my y1 is -2, my x2 is -6, my x1 is -6. So 3 minus -2. So keep, change, opposite means 3 plus 2, which is 5. And then -6 minus -6. Got to keep, change, opposite. So -6 plus 6 is a 0. And anytime you have a 0 in your denominator, it is undefined. If you think about what this is actually saying, when you have a fraction, let's say that you had 2/3 as a fraction. That's like saying that, okay, I have a pizza and I've got it cut into 3 slices, okay? So I've got that right there. This 3 means how many slices your whole is cut into. And this 2 represents how many you actually have. So there's 1, there's 2. So the shaded region represents how much you actually have of that pizza. So in this case, this is saying you have a pizza that's cut into 0 slices. Well, even if you have a whole pizza and you don't cut it at all, that is still considered one big slice. Because if you cut it into 2, now you have magically 2 slices. So there's no way you can ever have 0 slices of a whole. So it's undefined because you can never have 5 of nothing. So that's why we would write undefined. Contrarily, if you had 5 over 0, or not that one, 0 over 5, that's like saying, let's see if I can do this. One, two, three, four. All right, so let's just pretend that those were all in the same shape and the same size. So let's say that we have a pizza cut into 5 slices. That's what that 5 represents down here. If you have 0 of those 5 slices, then you have no pizza. That's why that would be 0. But whenever you have a 0 in the denominator, that's why we would write undefined. And you just saw none of that. I'm so sorry, guys. So this was my pizza that I cut into those 5 slices. I cut them all like this. And this is saying, okay, those are the slices that we cut them into. We have 0 of those 5. So now I have 0 slices. Okay. So on problem number 35, I've got y equals 2x plus 5. Find the slope and y-intercept of the line represented by each equation. So your slope is always the number in front of your x value. And just as a FYI, while you're doing these problems, if possible, you need to put it in that y equals mx plus b form. It's already in that form for number 35 and 36. So our m is always the number in front of x, so it would be 2. I would accept 2 or 2 over 1. And then for the b, your y-intercept, it's always that number by itself at the end, so that would be 5. For number 36, the number in front of your x is your -3 over 4, so that's your m. There is no b written, so we can just write plus 0 and say our b is 0. For number 37, we would subtract 5x from each side to get -2y equals -5x plus 10. And then I would divide each side by -2 to get y equals. Now a negative divided by a negative is a positive. So that would be a positive 5 over 2x. And then 10 divided by 2 is 5. So that's why we get plus 5 here. So our slope is 5 halves. And our y-intercept is a positive 5. So y equals -3. Whenever you have y equals just a number, remember these two are our special graphs. Those are special graphs. So when you have y equals a number, you're always going to have a slope of 0. And then your y-intercept is always whatever your number, or whatever your y is equal to. So it would be -3 in this case. For x equals a number, your slope will always be undefined, and you will never have a y-intercept. The reason, let me see if I can find it, is because when we looked here at problem number 27, notice how when we had x equals 5, it never crossed that y-axis. Never ever crossed it. So that's how it would be whenever you have x equals a number. So you would always have none written for that y-intercept. Next, for 40 through 42, the directions tell us to write the equation of the line with the given slope and y-intercept. The equation of a line is written as y equals mx plus b. So here they always give us our m, which is our slope, and they give us our y-intercept. Now they wrote our y-intercept as an ordered pair, but whenever they give you an x value for your first term, which is a 0, then that means that your second value is always what your y-intercept is. So y equals, our m is 2, so that would be 2x. Our y-intercept is 3, so it would be plus 3. On number 41, we have our slope is -2/3, so that would be y equals -2/3 x, and then your y-intercept is a +2, so I would say +2. And then for number 42, I have a slope of 3/4. That's y equals 3/4 x. Y-intercept is a -2, so I would write -2. If you wrote y equals 3/4x plus -2, that means the same exact thing. I would accept either answer. All right, next we're starting in section 3.3, which is normally where all of the students have their stroke. The directions say determine whether each pair of lines is parallel, perpendicular, or neither. Remember that parallel lines have your lines that never touch and your slopes are the same. Perpendicular lines are lines that intersect at a 90-degree angle, and their slopes are opposite reciprocals. If you need a little help remembering that, I would refer to the 3.3 video. So this says that L1 goes through these 2 points and L2 goes through these 2 points. L1 means line 1, L2 means line 2. So we're actually going to have to use that equation, that formula, m equals y2 minus y1 over x2 minus x1. So I label my x1, y1, x2, y2. And I have to find the slope of this line, and then I have to use the formula to find the slope of this line. And then I compare them. If they're the same, then the lines will be parallel. If they're opposite reciprocals, then they're going to be perpendicular. If they are neither one of those, you would put neither. So I have my setup here for that formula that I taught you how to do. So y2 is 3, y1 is -2, x2 is 1, x1 is -3. So now I have 3 minus -2, which is keep, change, opposite. So that gives me 3 plus 2, which is 5. And then 1 minus -3 is keep, change, opposite, which now means 1 plus 3, which is 4. So my slope here is 5/4. So now let's find the slope here. This is an x1, y1, x2, y2, if you can read that. So plug that into my formula. y2 is 8, y1 is 3, x2 is 4, x1 is 0. So 8 minus 3 is 5. 4 minus 0 is 4. So we have a 5 over 4 for our first point or first line, 5 over 4 for our second. So that means that our lines are parallel since they have their same slopes. Problem number 44, same exact type of problem. x1, y1, x2, y2. So I'm going to plug those into my formula. So y2 is negative 3, y1 is 1, x2 is 2, x1 is negative 4. So I have negative 3 minus 1. So that would be keep, change, opposite, which gives me negative 3 plus negative 1, which is negative 4. And then 2 minus negative 4. Keep, change, opposite. 2 plus 4 is 6, which simplifies to be a negative 2 over 3. Okay? So now to find the slope of our second line, I've got x1, y1, x2, y2. So my y2 is 0, y1 is negative 3, x2 is 2, x1 is 0. So I've got 0 minus negative 3. Keep, change, opposite. So that would give us a positive 3. 0 plus 3 is 3. And then 2 minus 0 is 2. So we have our two slopes. One is a negative, one is a positive, so they're opposites. And this one is a 2 over 3, and this one is a 3 over 2. So they are also reciprocals. So that's what you have as reciprocals, is when you flip that fraction. So since they are opposite reciprocals, that means that our answer is going to be perpendicular. So now let's look at problem number 45. This problem is a little bit different because instead of giving us 2 points and we have to find the slope, they give us 2 equations. But what we can do here is solve the equation for y by putting it in that y equals mx plus b form. And then we'll be able to find the slope because it's always the number in front of your x when it's in that y equals mx plus b form. So I have, oops, sorry guys. Turn the camera a little bit. X plus 2y equals 6. So to get the y by itself, I would subtract x from each side, which gives me 2y equals negative x plus 6. And then I would divide each term by 2, which gives me y equals negative. This is understood to be a 1 in front of that x. So that would be a negative 1/2 x plus 6 divided by 2 is 3. So my slope for this line is negative 1/2. Now I've got x plus 3y equals 9. So I'm going to subtract x from each side, which gives me 3y equals negative x plus 9. And then I divide by 3. So I now have y equals, again, this is understood to be a 1 in front of that x. So negative 1/3 x plus 9 divided by 3 is 3. Remember, the only thing we compare when we're determining whether lines are parallel, perpendicular, or neither are the slopes. We don't care anything about the y-intercept, so do not pay attention that they are the same number. It means nothing. So they're both negatives, but one is a 1 over 2 and one is a 1 over 3. So they're not parallel because they're not the same slope, and they're not perpendicular because they're not opposite reciprocals. So we would put, for this answer, neither. Okay, now let's look at problem number 46. Same way. So this problem is done the same exact way as the other one. So I've got 4x minus 6y equals 18. So I'm going to subtract 4x from both sides to get negative 6y equals negative 4x plus 18. And I'm going to divide every term by a negative 6. If you had just divided by a positive 6, then negative 6 divided by positive 6 would give you a negative 1y. We don't want a negative 1y, so that's why we did it by the negative. So those cancel out completely, leaving you with just y. So here, a negative divided by a negative is going to give me a positive here. And 4 divided by 6 is 2 over 3, x. And then 18 divided by 6 is negative 3. So our slope here is a 2/3. Now let's look at the other equation. So to get the y by itself, I have to subtract 2x from both sides to get negative 3y equals negative 2x plus 6. And then I divide by a negative 3 on each term to get y equals a negative divided by a negative is a positive. So that's a positive 2 over 3x minus 2. So my slope is 2/3. So since my slope on each of these equations is the same, that means my lines are parallel. Now let's look at problem number 47. Problem number 47, the directions tell you to write the equation of a line. Well, we know the equation of the line is y equals mx plus b. Well, in order to write the equation of a line, we need the m and we need the b. Well, our m, they tell us, is 2 over 3, so that part is easy. Now, all we need is the b. Well, we know that b represents our y-intercept. And we know whenever they give us an x for a 0 and then a number for our y, then that y value is the y-intercept. So our answer here is y equals 2 over 3x plus 5. All I did was plug in my 2 over 3 for my m and my 5 in for my b. So next, I've got a slope of 0. If you remember back, bear with me for just a second to find this. If you remember back on page 8, where we did problems 38 and 39, notice how whenever you have a slope of 0, you're going to have y equals a number. So on problem number 48, since we have our slope of 0, we know it's just going to be y equals some number. And since it's a negative 3, it would be y equals negative 3. Coincidentally, when we see problem number 49, our problem says that our slope is undefined. Whenever your slope is undefined, like here on number 39, you have x equals a number. So x equals, and then you find what your x value is, which is 4, and you are finished. So as long as you can get what x equals a number and y equals a number, the slope and y-intercept are, you should be good. Now number 50 is a little different. On problem number 50, we need to write the equation of a line. So we should always write y equals mx plus b. Once we know our m and our b, we know we can write our equation. So our slope is 3. They tell us that. And they give us an x and a y value. We do not have a y-intercept of 3 because that x value is not 0. So we have to use a little bit of creativity to find out what our b is. We can do that by plugging in our x, our y, and our m to solve for b. So y was 3, m is 3, x is 2, and we don't know what b is, so we're just going to bring it down. So to solve for b, I'm first going to multiply these two numbers. So I bring my 3 down, and then 3 times 2 is 6. Bring down your b. To get b by itself, you will just subtract 6 from each side to get b equals -3, because 3 minus 6 is -3. So our equation is y equals 3x minus 3. If you wrote y equals 3x plus -3, I would also accept that. So either one of those answers is correct. Okay, let's look at the last page of the study guide. So on problem number 51, the directions are the same. Write the equation of a line. So y equals mx plus b. You need your m and you need your b. So our m is 5/3, and we need to find what our b is. So I'm going to label these as x and y, and then I'm going to plug them into my equation. So my y is -2, my m is 5/3, my x is a 3 plus b. Now I'm going to put this 3/1 so I can see what my numerator and denominator are. So I'm going to multiply these two together first to get -2 equals 15/3 plus b. I got that by multiplying 5 times 3 is 15, and 3 times 1 is 3. And then I know 15 divided by 3 is 5. So I have -2 equals 5 plus b. To get the b by itself, I would subtract 5 from each side to get b equals -7. -$2 in the bank account, you spend $5 more, so now you owe them 7. So my answer is y equals 5/3x minus 7. Alright, next the directions say write an equation for the line satisfying the given geometric conditions. So they're saying, I want you to write your equation of a line, which is y equals mx plus b. And I'm only going to give you specific information about that line. You have to figure out the slope, and you have to figure out the y-intercept. Well, I always should write y equals mx plus b. That should always be step 1 when they ask you to write an equation for the line. Then you write your m equals and your b equals, because you know that's what you need in order to write the equation for the line. Well, they don't give me my m or my b, but I do know how to find my m when they give me 2 points. The way is by that formula. Is m equals y2 minus y1 over x2 minus x1. So I'm going to label each of these numbers, and I'm going to plug them in here. So y2 is 3, y1 is -1, x2 is 3, x1 is -3. So I have 3 minus -1, which is keep, change, opposite. 3 plus 1 is 4. And then 3 minus -3, we have keep, change, opposite. So 3 plus 3 is 6. So our slope, to simplify, would be 2/3. Now I'm going to plug this into my equation and one of my ordered pairs. It doesn't matter which. I don't like negative numbers, so I'm going to use this ordered pair. So my y is 3, my m is 2/3, my x is 3 plus b. I'm going to make that 3/1, which gives me 3 equals 2 times 3 is 6, 3 times 1 is 3 plus b. And then I know that 6 divided by 3 is 2. I'm going to bring everything else down. So now I subtract 2 from each side to get b equals 1, because 3 minus 2 is 1. So my answer for this, it's always an equation, so it would be y equals 2/3x plus 1. So next, for number 53, the directions say that your line has a slope of 3/4 and a y-intercept of 0, 3. Well, that's easy. You need to write y equals mx plus b. You know your m is 3/4, and they tell you your y-intercept is 3. So now all we have to do is plug it into our equation, which is y equals 3/4x plus 3. And we are finished with that problem. Sometimes they're going to be a little more intricate, like problem number 52. Sometimes they're going to be very easy and straightforward and to the point, like problem number 53. Now let's look at problem 54. It says L passes through the line through the point 4, -3 with a slope of -5/4. So this is a lot like problem numbers 50 and 51 that we did earlier in the study guide. So you should always say y equals mx plus b, m equals, and b equals. Whenever your directions say write an equation for the line, that's the first thing you should do. Well, they tell us our m is -5/4. So now we need to find out what our b is. We do that by plugging in the m, the x, and the y into our y equals mx plus b equation. So y was -3. My m is -5/4. My x was 4 plus b. Now I'm going to put that 4/1 so I can see what my numerator and denominator are. I'm going to bring down my -3 because I'm going to multiply these two numbers together first. Well, a negative times a positive is a negative. 5 times 4 is 20. 4 times 1 is 4 plus b. I know that -20 divided by 4 is -5. And then to finish this up, I'm going to add 5 to both sides to get 2 equals b. So, got a 2 here. So that means my equation is y equals -5/4x plus 2. Now moving on to problem number 55. L has a y-intercept of -4. So I've got y equals mx plus b, m equals b equals. Well, it tells me my y-intercept is -4. Easy. That part's done. And then it says, and is parallel to the line with this equation. Well, we learned that parallel lines have the same slope. So what we can do is solve this for our y equals mx plus b formula and then the slope of this line should be the same as the slope of our line because they are parallel. So I'm going to subtract 3x from both sides, which gives me negative y equals negative 3x plus 6. And remember, that's a negative 1 in front of that y, so I'm going to divide by a negative 1, which means y equals negative divided by a negative is a positive 3x, and then a positive 6 divided by a negative 1 is a negative 6. Remember, the only thing that is the same, because they're parallel, are their slopes. Y-intercept has nothing to do with it. We're not concerned with it at all. So since this line's slope is 3, and the slope of our line is parallel to that, well, then that means they're going to be the same slopes. So you would write this as y equals 3x minus 4, or you could write y equals 3x plus negative 4. It means the same thing. Okay, the final problem on this study guide is problem number 56. It says that L passes through to negative 1 and is perpendicular to the line with this equation. Well, I'm going to write my y equals mx plus b. I'm going to write my m equals and my b equals. Well, we know that perpendicular lines have slopes that are opposite reciprocals. So if I find the slope of this line, then I can find the slope of my line. So 3x minus 2y equals 5. Now subtract 3x from both sides to get negative 2y equals negative 3x plus 5. And then I'm going to divide everything by a negative 2 to get y equals a negative divided by a negative is a positive, 3 over 2, x. And a positive divided by a negative is still a negative. Remember, the only thing we're concerned with are the slopes. So this slope is a positive 3 over 2. Our line is perpendicular to this, which means it has to be the opposite. So since this slope is a positive, that means our slope has to be a negative, and it also has to be reciprocals. So since this is a 3 over 2, we're going to flip that to be a 2 over 3. So our slope is negative 2 over 3. Now we have to find our y-intercept. So we have y equals mx plus b. Our y is negative 1. We know that by labeling these here. My m is negative 2 over 3. My x is a 2. Bring down your b. I'm going to put that 2 over 1, which I'm going to bring my negative 1 down. Negative 2 times 2 is negative 4. 3 times 1 is 3, plus b. And to get that b by itself, I add 4 over 3 to both sides. So now we have to combine a negative 1 and a positive 4 over 3. So we need to get a common denominator, which gives us negative 3 over 3 plus 4 over 3. Okay? Remember, you need a common denominator when you add or subtract fractions. So a negative 3 plus 4 is a positive 1, and then you keep your denominator the same. So your y-intercept is 1/3. So our equation for this line is y equals negative 2/3 x plus 1/3. If you had one like that on the test where I gave you these crazy fractions down here, it would probably be closer to a bonus, but you still would need to know it just in case I put it on there. I hope this review has helped you prepare for your test 3. I wish you the best of luck.